Magnificent!
Hi, the Astro 30 here, and today I'll be going through putting this little radio kit together here. I bought it off of eBay for around about $8-9 about 3 months ago, and it's just been sitting around ever since. So I decided today was the day to put it together. So I'm going to take you through aligning it, some assembly tips, and also figuring out a fault that it had after it was assembled. I've got this, I believe it's a 7 transistor AM Superheterodyne radio kit from China. Paid about $8 for it, and it's been sitting around for the last 4 months, and I thought, well, today's the day to build it. Now, it's hot as a mother today, so what better day to do electronics than today? Right, so let's open the packaging and have a look at what we've got inside here. Now, there's a nice little hole here. I might use a screwdriver just to get the plastic started. Get that there. We don't need that bit of plastic anymore, but we do need a tiny little circuit board here. It's actually really nicely done, I must admit. There's the silk screen side and there's the copper side. It's only a single-sided board, but it's very well manufactured, kind of reminiscent of early day electronics, the old green lacquer there. This is our, well, schematic, and yeah, there's the schematic there. I'll show a better picture of it in a minute. The board layout and some stuff about resistors and transistors and stuff here, and of course it's all in Chinese, so yeah, and on the back it's all just in Chinese. Right, now I'm trying to figure out how to get into this. I think there's this little clip here which just separates it like that. It doesn't appear to have any like screw holes or anything in the back there, so yeah, it's just clipped together. So we've got a speaker, tiny little speaker here. Yeah, right, the size of the magnet on that. Pretty crappy looking speaker, isn't it? We've got a bag of parts, and of course we've got a dial indicator which is also got Chinese writing on it. And that's pretty much how it goes together. I've just noticed that the plastic is cracked here, which is a bit of a shame. But, alright. I mean, this part looks alright. It's all complete, doesn't have any cracks or anything in it. Yeah, but this piece has got a corner missing. I just unwrapped it like that, so I didn't do that. So with this dial indicator, it doesn't look like there's any backing tape or anything to pull off to self-adhese it to the plastic case, so I'm going to have to find some glue to glue that with. Alright, let's turn our attention to the schematic diagram here for a second. Over here, T1, that's the loop stick antenna coil. Now this topology is a 1, 2, 3, 4, 5, 6 transistor. I was close. This topology of the circuit is not actually a true superheterodyne. This first transistor here is both a mixer and a local oscillator all in one package. So that therefore makes this an autodyne, because only one device does both the mixing and the oscillating at the same time. And it's pretty basic. It's your RF amplifier, oscillator, mixer, first IF, final IF, preamplifier, audio, step-up transformer, power driver transistors, speaker. Let's talk about how a autodyne or superheterodyne works, and if you don't want to know this information you can skip this bit. Over here with this loop stick coil, this is what's known as a pre-selector, and this is also a tuned circuit. So say that capacitor was tuned to 1000 kilohertz or 1 megahertz. The oscillator over here has to be 455 kilohertz higher or lower than the selected input frequency. So we'll make it higher, which is 1455. So it would mix 1455 kilohertz with 1000 kilohertz to produce 455 kilohertz at the output of this mixed oscillator stage. And then it's just amplified by each IF stage at 455 kilohertz, and all these transformers in between are tuned to 455 kilohertz. Turning our attention now to B3, the third transistor, which looks like they're using it as the detector to detect the AM signal. And that's pretty common. You can use a germanium diode, or you can use a transistor. Now if we look carefully, this resistor, this 120K, that's our AGC line because it is fed back into the first IF transformer here. And it comes off of the collector of V3. So that's before it's detected. And then the output of the detector is taken from the emitter through the volume control. So yes, the AGC line is before the detector, and the resultant output is after the detector. And basically this transistor is also acting as an IF amplifier as well. The output's a pretty basic arrangement of a push-pull stage there. Nothing really spectacular about that. It uses two separate windings of the transformer there to get the positive and negative half cycles for each, and then just amplifies it and outputs to the speaker. It's really basic, and this only runs off of 3 volts, so 2 AA batteries by the looks of things. Now the inside of the case over here is where the batteries would go, and the speaker is mounted there, and the circuit board's also mounted in here, so everything is self-contained in here. So when this back panel, even though it's got a split in it or a crack, once this is removed, to get to change the batteries, yeah, you just pull it off, change the batteries, put it back together. Everything's all self-contained in here, which is a better design than the last radio I built. So I suppose it's about time that I plugged the soldering iron in and started populating the board with some parts. And speaking of parts, considering those parts are quite small, it's easy to get them lost. So it would be a very good idea to put them in something like I have there. That's just the plastic cup off of a piece of packaging that holds key tags. A set of key tags in it. You know, like key rings. And that's just a perfect little tub to put things in, so that's what I've done. Saves you losing stuff and then doing your nana trying to find where this sodding resistor has gone. Alright, I'm ready to assemble the board now. I'm not going to bore you with how to assemble the board. It's pretty straightforward. You follow the diagram and the printed overlay here on the circuit board. Use the schematic for the references what parts what, and just go ahead and assemble. I will say with assembly that you should start with passive components like resistors and capacitors first, then semiconductors, coils and other hardware last, because if you start putting big things like this transformer on the board first and then you're trying to solder in resistors and capacitors which are probably half the size of this in height, it makes it awfully difficult to get them nice and straight and flush with the board, and yeah, you're just painting yourself into a corner really. So always start with the small passives first and then move up to the larger components and semiconductors last. However, what I will do is I'll put this up on the desk facing down on what I'm doing, and I'll put it in a time lapse and you can see me assemble the board real fast. I'm going to assemble every component bar the LED. In the front panel of the case you'll notice there's a little hole where the LED is to poke through, and of course it's going to be screwed in here. So in order to line this LED up, you've got to put it into the board, screw the board in first and then solder it in, because otherwise it's not going to poke out that hole. Okay, well, progress. I've got all the resistors soldered in, and they're all soldered in the right place. So now I'm going to move on to the ceramic capacitors. There looks like there's only about 6 of them. Populate them in there. Well, my component count is going down. I've just got some electrolytic capacitors, a diode and some transistors to go. Here we are here, it's populated. So now I will move on to those components. And just one other thing, having a magnifying glass when working with components that are relatively small and it's hard to read their print is godsend. Okay, enough of that. Alright, so I've got the 4 electrolytic capacitors on there. There's 3 100 microfarads and there's 1 10 microfarad. I didn't film putting them in. I mean, there's only 4 of them. But I will film soldering them in. Okay, so I think it's time now to move on to those transistors. Okay, that's the transistors put in, and it also helps if this capacitor was put in the right place and the extra capacitor, which was a 10 microfarad left over, was actually put in where that capacitor was originally. I stuck them in the wrong place. Well, that one in the wrong place. I stuck it there instead of there. And I've corrected that now. Also, there's an error on this overlay. Up here in the power stage, they've marked this transistor as B4 where it should actually be B5. They've marked that one as B5, which should be B6, and this one is not really marked at all, but it says what value it is, which is handy, but that should be B4 there. So they haven't marked this transistor, but they've marked this one as V4 and this one as V5 instead of V5, V6. As the schematic says that this should be V5, this should be V6, and that one is V4. So just keep that in mind if you're assembling this kit, because the silk screen is actually wrong. Anyhow, moving on. Before I get too excited, I might want to start thinking about installing the board into the case and lining up my LED. Okay, with the board in its final resting place, that hole down here, it looks like you pass the LED in through that way to make it make contact with the front of the panel, and then just solder it from the top, well, from the bottom, but put it through the top. That looks like how I'm going to do it, but I need to figure out how long to bend the leads before the board. Okay, now that it's sitting in its hole, I can probably just at least get it started where it's supposed to be bent. That's perfect. I don't know if you can see that, but I've bent him at right angles there. It's about 6mm up. Bent at another right angles again, 6mm along. Put them through the holes. Now all I do is solder it in, and it lines up perfectly with the hole. Okay, so the LED is now soldered in, poking through the back side of the board, ready to accept into its receptacle. Next step I'm going to move on to is I'm going to move on to this variable resistor, volume control on-off switch, because that's smaller than the next components I'm going to install. Then I'll install the audio transformer, and finally I'm going to install the IF and oscillator coils. So that's going to be my next task. But before I do that, I'm going to go out and buy some super glue. I thought I had some, but pardon, I don't. Now I'm going to need super glue to glue this to the front panel, and I'm also going to need super glue to glue this speaker into the front panel, because there's no other hardware to mount it. And when doing electronics, there's nothing like a nice cold glass of Coke. Okay, and a short time later I've gone out and got some super glue, as I said I was going to do. So I'll open that and I will now glue that speaker in and glue the front fascia on. Okay, so now I'm going to start by gluing the speaker in, and well, don't think it really matters where it goes. There's a little locator here, but yeah, doesn't seem to locate to anything in the plastic work, so just going to put a few dabs. Ooh, that was way too much. Just a few dabs of super glue. Doesn't really matter if it gets on the driver or not, I suppose, but that should be enough. And sit it in there like that and hold on to it for a while and wait for it to go off. Okay, well that didn't take long, so now for the fascia. Don't need to put too much on here, just a little bit here and there sporadically, just so that the thing, especially in corners and such, has something to stick to. That should be plenty, so I'll leave that at that. Stick this on the right way up, which is there, and that should be it. Now this transformer is going to be a little bit of a problem. This one here is because it's got 3 pins on either side, so I don't know which side is which. Okay, the plot thickens. Now, investigating a little bit further, there's a tiny little rise here in the plastic of the transformer, a little dot, and if you look at the overlay, there's a tiny little dot there. Now, this is where that little dot or that notch on the transformer is located, so you put it that way around. Just a little FYI. I also noticed that they've got these bridge points which aren't soldered, so you'd solder them in. Now there's especially a little bridge mark here where the transformer is. My advice would probably be to actually join these break points. There's another one further down the line here. There's one here marked B, and there's one over here off screen marked A, which I probably already joined. I reckon that they should be joined. I'm going to bridge those gaps. If something doesn't work when I'm finished, I can always unbridge them. But I reckon that they should be bridged. There's no real physical reason for them not to be. Okay, the transformer's now soldered in correctly, and I've bridged all those other 3 broken connections there. Now all I've got to do is just trim off the ends of that transformer, and I can move on to the next step, which is putting in the IF coils. Now with these IF coils, this red one is obviously the oscillator, so that's going to be T1. This black one is the final IF, so that's going to be T4 according to this. Sorry, the oscillator's T2, and T3, the white coil, is going to be the first IF, so I'm just going to put them in the board where they go. It helps to put it the right way around. I was trying to put it in backwards, which is not going to work. Now this is going to be awfully difficult, and I actually succeeded first time. So what I'm going to do is I'm going to solder the 2 earth tag parts of the can, so at least it's sitting in the board. Okay, and I'm going to check that it's still straight, looks alright. I'll do the same for the other 2. Now it's just a matter of going around each of the transformers and soldering the rest of the leads. So was that one. So that's the IF transformers and oscillator Telstra. Alright, so that's my IF coils and oscillator coil soldered in. So the next thing I might attack is this little headphone jack, which goes up over there. Okay, done like a dog's dinner. Now it's starting to actually look like a radio. Well, it's starting to look like a circuit board anyway. What I might do is I might put the volume control knob on, which is sitting over here. It's got a bit of a tag on that. Well, it's gone. It doesn't really particularly matter which way around you stick this, as long as it locates properly on the knob, or on the shaft I should say. There's a really tiny Phillips screw to do. So I need me goddamn precision screwdrivers. Okay, well I don't know where my set of precision screwdrivers went. They seem to have off. But I found another screwdriver I can use in the meantime, which will just do the job happily. That's done up, and there's one little problem here, that capacitor's now on the way. Just bend him up out of the way. Okay. That's on, and it works. It switches on and off. Hooray. Now I need to turn my attention to this tuning capacitor or condenser, but I'm going to have to mount this little plastic thing on the board that holds the ferrite rod in on top of the board first, before putting the capacitor in and soldering it, and also screwing the capacitor down. So what would be easier would be to bend these tags where they're supposed to be, put the capacitor in and the plastic bracket, and then screw it together before soldering it. Right, so now I've got them started, I'll slip the bracket underneath so the whole assembly is now one, and turn it over, and now I can put the two mounting screws in, and there's three of them, one's for the knob. Tighten them, slowly bringing the capacitor down to the board and to the plastic bracket until it's tight. I'm doing it this way so I don't put the thing into a bind or make it look cockeyed or what have you. I think that's going to be tight enough now. So now I'm going to retrofit the knob and see if it interferes with the capacitor leads that are sticking up at the moment. Okay, now I can insert my ferrite rod bar into the bracket, like so. It's probably going to need a little bit of super glue or something just to hold it there once it's in the case. And then I can slip my loop stick over the end of the ferrite rod. Now if we look at the piece of paper diagram thing here, you've got A, B, C and D. Now this one's got 100 turns on it, so that's the primary, and this one's only got 10 turns on it, so that's the secondary. These two wires here have a different colour to this coil, so the two red ones, or dark maroon colour ones that are sticking out is the primary, and these two little N ones are indeed the secondary. Of course you've got to get this in phase or it's not going to work properly. So in order to get this in phase, that's one end of it, that's the second end of it, that's one end of that coil, and this one all the way over here is the end of that coil. So that means that this should be A, B, C and D in that order. So that's what I'm going to do. Now with it sticking on the ferrite rod with A sticking out there, B sticking out there, C there and D there, I've noticed that it's just A, B, C and D on the circuit board there. So what I do is just place each wire through each relative hole, solder it in and call it a day. Well, after fiddling and farting around for a bit, I managed to get one of them to go through the holes. So I'm just going to do one at a time. Get them soldered in and then just work like that. Now I found it much easier to take the ferrite rod off and the knob off because it was in the way. And I've threaded through my wires through the holes that they need to go through. It's got to push them back through. I threaded them through quite a fair distance just so they would stay in place. That's one. Now I can solder that one in. So now I can put my ferrite bar in wherever it's gone and coil as one assembly. And there we go. So far that's actually now assembled. I've got to put the knob back on, but that's not that great of a deal, bigger deal. And now we can do some wiring to get power to it and get it output to the speaker. Now as you can see, I've put the knob back on and now I'm going to stick the little indicator sticker, this thing, on it, and I've rotated it all the way in the direction it needs to go, which is that direction, because this is the side where the controls come out of the front. And if you turn it over, you'll notice it's upside down, but it says 1600 is up here, so I'm rotated to minimum capacitance at the moment, so it has to rotate that way, so that when it's rotating in a anti-clockwise direction like that, it ends up on 530. And you just sort of have to guess the center. It doesn't have to be accurate, it just has to be, you know, pretty close. Somewhere like that. And I hope that's it, because I won't be able to get the capacitor off without taking the sticker off now. But that should be right. I've got, it's a little off, but that's fine. I've got a connection point here and two here and one there, so my rest of my connection points with my wires are all around this side of the board. So sweet. Okay, now that the board is assembled and there are no parts left over, I can turn my attention now to soldering on the speaker wires and also inserting the battery clips. Now it's not marked inside the case which way around the batteries go, so depending on which way around you stick this will denote where your positive and negative ends are. So this is the plate that joins the two batteries together. So if I put it round that way, for instance, and push it in, and then use a screwdriver to push it all the rest of the way down, that now means that my tab here with nothing on it, no spring, is the positive lead, and that will go here, because it will go positive, negative, positive, negative. So this one with the spring on it, this one here, this one with the spring on it is the negative. So that will go there. Okay, I've got two brand new ever ready AA batteries. And that one goes that way. And that looks reasonably alright, looks nice and straight anyway. I'll now do a quick voltage test and see if I've got 3 volts there, which I should have. Yep, 3.23 or 3.24, so that's perfectly fine. This kind of reminds me of play school when they used to do things to the audience upside down to themselves, but the right way up to the camera. Okay, now I've looked on the speaker here and there is no marks denoting which one is positive and which one is negative, so I don't think it really matters. First I'll bend these over a little bit because I don't really want to stick myself every time I put batteries in it. Okay, so looking at this, the two yellow speaker wires go across here. The negative 3 volt goes to that pad there, and the positive 3 volt goes to this pad right in the corner here. You might not be able to see that on camera, I'll just move it over a bit. That pad right there. So you don't need to see me doing that, I'll just solder them in and then we'll slip it in the case. Okay, that was a bit more painful than it needed to be. These wires are just way too short, as usual. So now I've got it in, I'm going to screw the board down home for the final time and lose the screw. So I'll use this flat blade which is magnetised, because I don't think I need to pull up the board to do anything now. I'll just make sure that that's clear. Well, that's screwed in. Everything seems to move freely. Now I've just got to reattach these two wires. I can just barely make the connections. So thank you, China, for giving me the shortest possible wires necessary for the job. Right, but they're in there now, so I'll poke those wires down out the way and poke this one down in there, out of the way too. Okay, now we're ready for some power and see if this thing makes any rude noises. Not that kind of rude noise. Okay, turn him on. I can see the LEDs lit up and it's pointing in the right direction. Okay, a short time later, guys, I've got it working. There was two problems. There was a bridge, solder bridge across one of the IF transformers. I fixed that. Then I wasn't getting any sufficient audio output, and it turns out that the points across this audio transformer, here and here, this is one side of the secondary, and it turns out one side goes to the base of VR5 and the other side goes to R8. That's one secondary there, and there's the other secondary there. Now the transformer is a bit weird how they've wired the pinouts, but that's beside the point. This junction here was open circuit, so there's something wrong with the windings inside the secondary of that transformer. So what I had to do is I roughly aligned the oscillator just to get some sound out of it, and the IF coils, and I just put a bridge across where the secondary should be for that transistor, and now I've got quite a considerable amount of output coming out of it now. So yeah, so one of these windings is open circuit, so I've had to jerry rig it. I mean, it probably would have only been like a resistance of about 1 or 2 ohm, so putting a bridge there, yeah, at least it works, that's the main thing. Now I'm going to take you through the alignment procedure. Okay, for this alignment procedure you're going to need another AM radio, tuned to around 985 kilohertz, and you're going to tune this all the way down to 530, so fully anti-clockwise. I believe that's anti-clockwise. Yeah, anti-clockwise. And I've backed out all the slugs here, so they're just touching the tops of the can. Now there's a lot of noise on this radio. I'm going to start adjusting the oscillator coil. See how it just went null there? That means that this oscillator is now beating with this radio here. So that should be about right where the oscillator should be. So I'll turn that off. Now I'll turn this volume up. I'll turn it to a radio station. So we know the oscillator's working. So now I'm going to peak each of these IF transformers until I get the loudest response. Takes a while. Right. I've lost it there. I just tuned it to a weaker station and peaked them out and by backing them off a bit, and it's come out a lot louder. You want a weak station because the ALC, or AGC I should say, in the circuit is going to overcompensate by limiting the bandwidth on these, well actually widening the bandwidth on these two IF transformers the louder the signal is. So you will not be able to peak it properly. So I think for the most part it's aligned. If I really was worried about, you know, aligning the scale and everything, I would tweak the antenna and the oscillator capacitors here in the condenser, and I'd move this up and down a bit. But really, for what it is, what's the point? Okay, that's about as good as I'm going to get it. I'm receiving all 5 stations, but the scale's still out. If I fiddled with it a little bit more by adjusting this trimmer, moving this back and forth on the rod, and playing with the oscillator setting, I would get it pretty much well aligned. But as I said before, what's the point? It's just a cheap $8 project. It's not really worth it really in the end. So now that I've got it working, and even though I had to bridge one of the secondaries together, you shouldn't have that problem that I had, but yeah, things like this happen. There was something wrong with the transformer when it was manufactured. It's open circuit, who knows why. So I think I can now just put a dab of super glue on either end of that coil there to stop it moving up and down the rod, and put the lid back on and call it done. Dab there. My interest, which is really what is going on inside. We make these decisions, these frenzied, and there we go. Done. And that's pretty much it. It's all done, put together and working, even though I had some trouble as I stated, but I managed to fix the problem by doing a little bit of basic circuit tracing. But I figured it out and got it to work to the most part. It's roughly aligned, doesn't have to be perfect, as long as it's oscillating correctly and the IFs are peaked roughly to their loudest point, then it's working as a superhet. Anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. Always like new likes on Facebook. Anyway, this is the Astro 30 saying, see ya, have a great day, happy electronics.